Okay, we're going over solving quadratic equations by factoring. So in chapter 5, we went all over factoring. That was 2 chapters ago. That factoring is very important because we now are going to be applying it to quadratic equations. Now, this quadratic equation is set equal to the number 15. In order to solve for x, what we need to be doing is setting our quadratic equations equal to 0 if we're in standard form. Notice this looks closest to standard form right now. Okay? So what we're going to do is we're going to move this 15 to the other side of the equation. And we're left with 6x squared minus x minus 15 is equal to 0. Perfect. So, we're solving for 0. Now, normally, what is usually on the other side of the equation? We usually have another variable. What is it? Anyone remember? Y. This is usually y. So, in other words, I want you to think of this 0 as the y value. When y is 0, where are we on a graph? Anyone know? We're on the x-intercept. That's right. We're on the x-axis, which means we're finding the values of the roots or the x-intercepts. Okay? So this factoring is going to help us find these two values here. That's why we went over factoring. It was very important that we know how to do that in order to work on our next set here. So we're going to be going from standard to factored form. Okay? We're going from standard to factored form. Yesterday we went from standard to vertex form, and that helped us find the vertex, which is a max or a min. Today we're going from standard to factored form, which will help us find our x-intercepts. Okay? So all of those skills are important because we're going to use them to now find parts of a parabola. This question here, we're going to need to factor it. If you guys recall, when we're factoring, we take the factors of the first term. What are the factors of 6x squared? Okay, so there's 3x and 2x, and 6x and 1x. Okay? After we've done that, so that's the a value factors. We take the c value factors. What are the factors of 15? Okay, so 1, 15, and 3 and 5. Good. Remember that we're going to be multiplying them in columns, and they're going to need to add up to what value? That's right, our b value, which is in this case negative 1x. Okay, so we'll set them up into columns here. We have our red columns. So those will be for our first terms, and only one set of red columns will be the first terms. And then we're going to have our green columns. Only one set of these columns will be our second terms of brackets. Okay? So we're going to use trial and error to figure out which pairing is going to work best. So let's start with 3x and 2x. 3x times 1 gives me 3x, and 2x times 15 gives me 30x. Any combination of 3 and 30 give me negative 1? No. Okay, so we went straight across. Now we go diagonally. 2 by 1 and 3 by 15. That gives us 2x and 45. Any combination of that work? No. Okay. We're still going to stay on 3x. We're going to try the second column this time. 3 by 3 and 2 by 5. That gives us 9x and 10x. Any combination of that work? Yes. Yes. What will have to be negative in order for this to work? The 10. That's right. This 10 will have to be negative. So that means the 2 by the 5, that means this 5 will have to be negative. So let's try this out and see if this is going to work. We'll do it in blue. We did 3 by 3 and 2 by 5. So that'll give us 9x and 10x. Okay? Now, if the 5's negative, what is positive 3 times negative 5? So, are they proper factors? Yeah, because this is a negative, so we know that these two will work. So that's fulfilled all of our requirements. They definitely multiply to our last value, and we now know they add up to our negative value in the middle. So our columns now, when we go to put it like this, the 3x is going to go into 1 as the first term. The 2x goes into another, because that's the column we chose, so that's the first term in each. Now remember this part. Because we multiplied the 3x times the positive 3, they have to go in opposite brackets. Okay? So the positive 3 goes in this bracket here. And because we multiplied the 2x times the negative 5, the 2x and the negative 5 have to go in opposite brackets. So the negative 5 goes here. We're still set equal to 0. So that's why we spent a whole chapter on factoring, because we have to be pretty proficient with this at this point. Now that we have this, we can solve for our zero values. Okay? So I want you to think of this. We have two terms here, okay? And they're multiplied by each other. In order to multiply a term by another and get 0, what do one of these have to equal? 0. One of these must be 0. So we're going to test for both of them being 0. Okay? So we'll test for both of these being 0. So that means we're going to set the first bracket, 3x minus 5 equal to 0. And we're going to set the second bracket, 2x plus 3 equal to 0. Now that they're set equal to 0, we're going to solve for x. When I move negative 5 over, what does it become? Positive 5, good. And then to isolate x, what do I have to do with that 3? We got to divide by 3. So x is equal to 5 over 3. You can put it as a decimal or a fraction. Both are okay. That's one possibility. The other possibility, let's move this 3 over. We get 2x is equal to negative 3. And to move the 2 over, what do we have to do? Divide. X is equal to negative 3 over 2. So, what this means is we have two values for x-intercepts. In other words, we have one value that crosses at 5 over 3, which is 1 2/3, let's say. So say this was 1, this was 2. 1 2/3 is probably about there. And then we have negative 1, negative 2. Well, negative 3 over 2 is also the same as negative 1.5. So that's another spot there. Okay? So these are our two x-intercepts. And quickly, from the beginning, which way does this parabola open? Up or down? Up, because our a value is a positive. So we know we have something that looks like this. We're not sure where the vertex is yet, but we know it crosses this point here, probably comes down, and crosses this point here. Those are our x values. So we know x can be either negative 3 over 2 or positive 5 over 3. Okay? So in order to do all that, we had to factor, make sure it was set equal to 0, split the equation so that we set each bracket equal to 0, and then solve for the two different x's. Okay? There's a lot of steps there.